Welcome to my channel Mathematical Clinic of Subash. Today we are going to discuss some of the algebraic problems of limits. Actually, algebraic function, limit of algebraic function can be categorized into three groups. One, taking the form 0 by 0, algebraic function taking the form 0 upon 0. If any algebraic function is taking the form 0 upon 0, then to determine its limits, we have three methods. First method one is factorize. Second one is rationalize. And third one is the formula. Formula we established is limit x approaches to a x to the power n minus a to the power n divided by x minus a equal to n a to the power n minus 1. Once again, if any algebraic function taking the form 0 upon 0, then to determine its limits, there are just three methods. First method one is factorize. You factorize to get the answer. Second one is you rationalize to get the answer. And third one is you apply the formula limit x tends to a x to the power n minus a to the power n divided by x minus a equal to n a to the power n minus 1. Let us do some of the numericals of the algebraic function taking the form 0 upon 0. First numerical one is limit x tends to 2 x square minus 5x plus 6 divided by x square minus x minus 2. If you substitute x equal to 2 here, it becomes 2 to the power 2 equal to 4, 4 plus 6 equal to 10, and here 5 into 2 equal to 10, 10 minus 10 equal to 0, downward 2 to the power 2 equal to 4, minus 2 is 2, minus 2 is 0, it is taking the form 0 upon 0. This is the pure algebraic function and taking the form 0 upon 0. So to find its limits, we have to follow these three steps, either factorize or rationalize or formula. Cause this one is not in the form of this formula, we cannot apply formula here. Cause there is no square root included, we won't follow this process, rationalize one. So we are left with only one process to solve this, and that process one is factorize. First of all, we'll have to write this function. This function takes the form, which form 1? If you substitute x equal to 2, then it is going to take the form 0 upon 0. 0 upon 0 when x equal to 2. So if you substitute x equal to 2 here, then function is going to take the indeterminate form 0 upon 0. And cause it is an algebraic function and taking the form 0 upon 0, we have three methods. Here first method will apply, factorize. So let us factorize it. This one is limit x approaches to 2 as it is. Let us factorize this one. This becomes x square minus 5x can be written as 3x minus 2x plus 6 as it is. Downwards also 2 can be written as x square minus 2x plus x minus 2. We have simply factorized first into last factor. This is limit x approaches to 2 as it is. We are going to take x common from first two terms, left with x minus 3. Again minus 2 common from both of them, left with x minus 3. Downward same thing. If you take x common, then left with x minus 2. If you take 1 common, then left with x minus 2. Let us simplify. It becomes limit x approaches to 2. X minus 3 is taken common. You are left with x minus 2. Downward x minus 2 is taken common. You are left with x plus 1. X minus 2 will cancel. Substitute x equal to 2 here, it becomes 2 minus 3 divided by 2 plus 1, and this is not other than minus 1 upon 3. That's the answer. Let us move to second numerical one. Second numerical is limit x approaches to 1, 2x minus 3 times root x minus 1 divided by 2x squared plus x minus 3. If you substitute x equal to 1 here, this becomes 2 into 1 minus 3 equal to minus 1. This is not going to harm us. and this becomes root 1 is 1 minus 1 equal to 0, so numerator is 0. Denominator will be 2 plus 1 equal to 3 minus 3 equal to 0. So if you substitute x equal to here, then it is again going to take the form 0 upon 0. That I'm going to write here. This function takes the form 0 upon 0 when x equal to 1. So again, algebraic function taking the form 0 upon 0, we have three methods: factorize, rationalize, and formula. Here there is the root, so you can even rationalize, but this problem can be done without rationalizing. If you factorize the denominator, this root x minus 1 will be cancelled, and simply we can get the answer. So that rather than rationalizing this one, let us factorize. It becomes numerator limit x tends to 1 as it is, in numerator 2x minus 3 as it is, root x minus 1 as it is. Denominator, let us factorize, it becomes 2 3 is 6, 2x square plus 3x minus 2x minus 3. This can be written as limit x approaches to 1, 2x minus 3 as it is, even root x minus 1 as it is. Let us take x common from both of them. We will be left with 2x plus 3, and again minus 1 common from both of them. You will be left with 2x plus 3. So the result becomes limit x approaches to 1 as it is, 2x minus 3 as it is, even root x minus 1 as it is. In the denominator it is 2x plus 3 common. You are left with x minus 1. Here limit x approaches to 1 as it is, 2x minus 3 as it is, root x minus 1 as it is, by 2x plus 3 as it is. Can you write x minus 1 as root x minus 1 into root x plus 1? A square minus b square can be written as a minus b into a plus b. These two will cancel. Substitute x equal to 1. You will get in the numerator 2 minus 3 equal to minus 1. In the denominator 2 plus 3 equal to 5. And this one 1 plus 1 equal to 2. So the answer will be minus 1 upon 10. Move to third question 1. This one is also algebraic function. If you substitute x equal to 2, this will also take the form 0 upon 0. So you will have to write this function takes the form 0 upon 0 when x equal to 2. This one is algebraic function taking the form 0 upon 0. Again, there are just three methods: factorize, rationalize, and formula. Here you will have to rationalize because you are given with expression inside the square root. Let us rationalize it. Apply the second process to find the value of the limit. This becomes limit x approaches to 2, root x minus root under 6 minus x square as it is, by x minus 2 as it is. Let us rationalize the numerator. The result becomes root x plus root 6 minus x square. We are simply rationalizing, nothing else. Root x plus root 6 minus x square. Simplify it. It will be limit x approaches to 2. Numerator becomes x minus 6 plus x square divided by denominator is x minus 2 times root x plus root 6 minus x square. Let us simplify it. This is limit x approaches to 2 as it is. Let us factorize this result to 1. First of all, we'll have to edit this one. Thereafter factorize. I am going to do directly. X square 6 can be written as, this x can be written as plus 3x minus 2x. Can you? And minus 6 as it is. Divided by x minus 2 into root x plus root 6 minus x square as it is. This limit x approaches to 2 as it is. We are going to take x common from both of them. Left with x plus 3, and again minus 2 common from both of them. You are left with x plus 3 divided by x minus 2 times under root x plus under root 6 minus x square as it is. We are going to take what common from numerator? X plus 3 in both, so x plus 3 common. Left with x minus 2 in the numerator. Denominator 1 is x minus 2 as it is, and even root x plus root 6 minus x square as it is. This x minus 2 will be cancelled, and if you substitute x equal to 2 now, it becomes 2 plus 3 equal to 5 in the numerator, and here root 2, and this one becomes also 2 to the power 4, 6 minus 4 equal to 2. This becomes root 2 plus root 2. This is exactly 5 upon 2 root 2. That's the answer. We are moving towards the fourth question one. Fourth question is similar question. Algebraic function. This function will also take the form 0 upon 0 when you substitute x equal to 2 there. So there are just three methods to find the solution. First is factorize, second is rationalize, third is formula 1. You can very easily judge that this one is the problem of rationalization, because both numerator and denominator are consisting square roots. Let us rationalize, and here we'll have to rationalize numerator as well as denominator. So the result becomes limit x approaches to 2. First question as it is, x minus root under 8 minus x square divided by root under x square plus 2l minus 4 as it is. First we are going to rationalize the numerator. It becomes x plus under root 8 minus x square divided by x plus under root 8 minus x square. Thereafter going to rationalize the denominator. This becomes under root x square plus 2l plus 4 divided by under root x square plus 2l plus 4. Let us simplify it. Simplify it. This becomes limit x approaches to 2 as it is. A minus b into a plus b will be, this will be x square minus 8 plus x square divided by, here a minus b into a plus b will be x square plus 2l minus 16, purpose is 16, a square minus b square. In the numerator you are left with under root x square plus 2l plus 4, and in the denominator it is x plus under root 8 minus x square. Very simple. Simplify it. This becomes limit x approaches to 2 as it is. X square plus x square will be 2x square, and it is minus 8. If you are taking 2 common, then minus 4 divided by, this is x square minus how much? 12 minus 16 equal to 4, and this expression as it is under root x square plus 2l plus 4 divided by x plus under root 8 minus x square as it is. These two will be cancelled, and substitute x equal to 2. What happens? This 2 as it is. If you substitute x equal to 2 here, then 12 plus 4, 16th root is 4 plus 4 equal to 8 in the numerator, and here 2, and this one will be also 2. 2 plus 2 equal to 4 in the denominator. 4 to the 8, so the result will be 2 to the 4. That's the answer. Move to next question 1. Question number 5. It is limit x tends to 0, x to the power 5 minus a to the power 5 divided by x4 minus a4. This function is again taking the form 0 upon 0 when you substitute x equal to 0 there. Sorry, it is x tends to a. If you substitute x equal to a here, a to the power 5 minus a to the power 5 is 0, and here also 0. So again it is an algebraic function and taking the form 0 upon 0. Actually, as I told you that if algebraic function is taking the form 0 upon 0, then to determine the limit there are three methods: factorize, rationalize, and formula. We have applied two methods, factorize and rationalize till now. Now we are going to apply the formula. The mechanism of formula 1 is limit x approaches to a, x to the power n minus a to the power n divided by x minus a equal to n a to the power n minus 1. This one is the formula. Let us think, how can we apply the formula? Formula can be applied only when three conditions are satisfied. The first condition is the power must be same, here n, here also n. Second condition is if here x, then here also should be x. And third one, here a, then here also should be a. If you are able to reduce the expression in this form 1, satisfying these three conditions, only then you can apply the formula. This one is not in that exactly given in that form, but we can change it in that form by using a simple technique of algebra. That technique is x to the power 5 minus a to the power 5 as it is. You need x here, a here. Let us do so. X minus a. And even in the denominator, x to the power 4 minus a to the power 4 as it is. You need x here and a here. That is why we have divided both the numerator and denominator by x minus a. And now we can apply the formula here as well as here. If you apply the formula here, power is same, base are matching, power is same, base are matching. So apply the formula here. The formula 1 is you multiply by power, write second as it is a to the power 5, subtract 1 from the power. Here also apply the formula, you multiply by the power, write second as it is a to the power 4 and subtract 1 from it. The answer will be 5a to the power 4 divided by 4a to the power 3. 3a will be cancelled and you will be left with 5 upon 4a. That's the answer. Move to next question 1, sixth question. This one is also an algebraic function. If you substitute x equal to 64 here, the sixth root of 64 is 2. Minus 2 is 0 and here 4 minus 4 is 0. This is also an algebraic function taking the form 0 upon 0. This one can be also reduced to the form of the formula, but you will have to apply some algebraic techniques here. The technique one is x approaches to 64 as it is. This can be written as x to the power 1 upon 6 minus 2 and this as x to the power 1 upon 3 minus 4. The technique is limit x tends to 64 as it is. We are going to write 1 in the numerator. And this x to the power of 1 upon 3 is going to be written as x to the power 1 upon 6 whole square. Can you? 2 3 is 6. It will be x to the power 1 upon 3. And this 4 can be written as 2 to the power 2. And numerator have been kept here. X to the power 1 upon 6 minus 2 here. So, here we are matching with the formula. Conditions of formula. Power are same. Base matching. So, you can apply the formula here. 1 in the numerator as it is. If you apply formula here, you multiply by power 2 and write 2 to the power 2 minus 1. This is not other than 1 by 2 into 2 equal to 1 by 4. Move to next question. Next question is limit x approaches to 0, third root of 1 plus x minus third root of 1 minus x divided by x. If you substitute x equal to 0, here it becomes 1. This one also 1. 1 minus 1 equal to 0 by 0. Again, it is an algebraic function taking the form 0 upon 0. So, just three method. Factorize, rationalize and formula. Here we are going to apply the formula. Limit x tends to 0 as it is, cause this can be written as 1 plus x to the power 1 upon 3. And this y as 1 minus x to the power 1 upon 3. Now, you know that to apply the formula, three conditions should match. Power is matching, first condition is satisfied here. Because here it is 1 plus x, you must have 1 plus x here. And here 1 minus x, you must have 1 minus x here. We are doing so. By doing so, have you made any change in the given question 1? Not at all. Because, 1 and 1 will be cancelled. And x plus x will be 2x. Yes, we have made the change. Because in the question has just x, but now by calculating we can get 2x here. So to balance it, we will have to multiply by 2. Getting it? If you simplify it, the result will be 2x. But you were given with x. So to remove that 2, 1 we have multiplied by 2. This 2 will be kept ahead, and we are going to apply the formula here. How can you apply the formula here? Yes, this is in the form x to the power n minus a to the power n divided by x minus a. So now we can apply the formula 2 as it is. Now a is, you can take a the variable is involved in both the expression, then a can be kept either first or second. You can take any of them. We are taking second as a, so a is 1 minus x to the power 1 upon 3. Sorry, the formula 1 is first you multiply by power 1 upon 3. Thereafter formula 1 is n a to the power n minus 1. So first you multiply by n is 1 upon 3, and a can be kept any of them because both are consisting variables. I am taking this one 1 minus x as a to the power n minus 1. N minus 1 will be 1 upon 3 minus 1. But here x is approaching to 0, so in place of x we are going to substitute. So the result becomes 2 upon 3 and 1 to the power finite number equal to 1. That is why it is 2 upon 3. Once again, I am going to tell you from the beginning. This question is limit x approaches to 0, third root of this minus third root of this by x. If you substitute x equal to 0, this is going to take the form 0 upon 0. So we have decided to use the formula here. This third root is written as power 1 upon 3. This one as power 1 upon 3. X as it is. Rather than x, we have changed this one in the form of formula x to the power n, a to the power n, then x and a here. If you do so, it becomes 2x, but in question it was x, so balance it we have multiplied by 2. We have applied the formula here, 2 as it is. The formula 1 is n a to the power n minus 1, n is the power 1 upon 3, a is we have taken here the second one, and substituted x equal to 0 to the power 1 upon 3 minus 1. Simplified it and got the answer 2 upon 3.